Hi guys, so this one we're going to explain velocity time graphs. So if we look at a velocity time graph, there's two pieces of information we can get. We can always figure out what the acceleration is, and we can get the acceleration because the acceleration is always going to be the gradient of the lines. And we know to find the gradient of the lines, we always do our vertical divided by our horizontal. Or your math, you might call it maths, you might call it the rise over the run. So again, if I break my graph up, because I can see there's three different things happening here, because there's three different shaped lines into section A, section B, and section C, I can calculate the acceleration of section A, because what I do is I find the gradient of that line. So the change in height is it went from 0 all the way up to 20. So the rise, or the height there, is going to be 20. And I divide it by my horizontal, or my base there, or my run there, which is from 0 to 5, so 5. So 20 divided by 5 gives me 4, and acceleration is always meters per second squared. For section B, if I want to find the gradient of that line, there is 0 height. So because it's 0 height, I'm doing 0 divided by from 5 to 10. 0 divided by 5 just gives me 0 meters per second squared. It's not accelerating because what it's doing is it's traveling at a constant speed, because at 5 seconds its speed is 20, at 6 seconds its speed is 20, 7 seconds its speed is 20, 8 seconds speed is 20. So in section B, it's not accelerating because it's actually traveling at a constant speed of 20 meters per second. Section C, I can see the speed is dropping. So it's not accelerating, it's not getting faster, it's slowing down. So to calculate in section C, I do the change in height. It starts at 20 and it drops down to 0. So it drops by 20, so it's negative 20. And we're dividing it by, it starts at the line 10 and it ends at 15. So that change there is 5. My base is 5, and the base of my triangle is 5. So negative 25/5 gives me negative 4 meters per second squared. This Easter, we're offering intense exam GCSE and A-level courses covering the entire curriculum, and the best thing just starts from 20 points. So it's a limited time offer, so remember to click the link in the bio to get it. It's negative because again, it's not speeding up, it's slowing down. The other thing we can find out from our velocity time graphs is we figure out about displacement. Okay, and what displacement means is just another way of saying the distance. Okay, so again, velocity is just another way of saying about speed. Displacement is just another way of saying about the distance traveled. M-E-N-T, or the distance traveled. And that's going to always equal the area under our graph. So if I want to figure out the total displacement, what we do is we find out what our area or total distance traveled is always going to be the area under our graph. Okay? So to find the area under the graph, this first section is a triangle. So what I'm going to do is 1/2 of the base